All right, so as a reminder of what we did with graphing, we said that when it came to the graphing notes, we would actually have these three examples here. Now, when it comes to the algebraic part, it's actually the same exact three examples, but now we're actually going to work them out algebraically. So if you look back at what we did for example 1 for graphing, it matched the same answers that we said for example 1 algebraic. So when it comes to example 2 for algebraic, our answers should be, again, to match up with this, negative infinity to negative 2, and then negative 1 to positive 2. So that's what we said graphically. So algebraically should match that. So let's go ahead and check and make sure we actually can get a matching answer here. So again, these are the same types of stuff. Now with this, it's very important that you guys remember how to do factoring and algebraically work things out easily. So again, step 1 said we're going to move everything over to one side. So here, we're going to subtract 4x from both sides, and we're going to subtract 4 from both sides. So that way we get everything to one side. But nothing combines here because none of these are like terms. All right, so just looking at this, again, our whole goal is to see where this whole function now is less than or equal to 0. So when we start looking at our numbers here, we're going to look at where the numbers are less than. So in other words, when we get to step 4 and we actually are working things out, we're looking for where we get negative numbers. So less than 0. So if we get a negative number, that's what we're looking for. But again, with the equal to sign, that means that we're going to use our brackets here. All right, so step 2 says we're going to need to factor this down or solve this out as if it were this function equal to 0. Okay, so with this, we're going to have to learn a factor by grouping. Now, you've seen this before. It's not the first time you're hearing it, but it might have been a little bit since you've done it. So with that, what we're going to do is we're going to factor out things, and we're trying to get them so that they have the same factors. So if we look at it, we're going to group these first two right here and the second two, and we're going to pull out what they have in common, factor out what they have in common. So we're going to factor out what's in common here. So looking at x cubed and x squared, we factor out an x squared here. They both have an x squared inside of it. Look at the second one, there's a negative 4 that's in both of them. So we factor out the negative 4. So if you take it back, negative 4 times x is negative 4x. Negative 4 times 1 is negative 4. And then x squared times x is x cubed. X squared times 1 is x squared. Okay. Now the next thing we said we're going to factor out what is in common. And again, this equals to 0. Sorry about that. So we're doing this multiple times. Factor out what is in common. All right, so here, what's in common is x plus 1. So we go ahead and put that in front, factor that out, pull it out. And what's left over is x squared and a negative 4. So we do x squared, negative 4. So x squared minus 4 equals 0. All right, so we're factoring by grouping. Okay, so with that, we're going to go ahead and set both of these equal to 0. Both zero product principle, in other words again. So we'll do x plus 1 equals 0. We'll do x squared minus 4 equals 0. So x equals negative 1. And this next one, I'll go ahead and take my time through it. We talked about this already when we did complex numbers. Remember back last week when we did this? We take the square root of both sides, and because it's quadratic, it's a squared there, that means we have two solutions here. So plus or minus 2, sorry. All right, so we get those three answers. So for step 3, we're going to put those on the boundary line, or on the line, and do as our boundary points. Sorry about that. Let's fix this. It's in order. So -2, then -1, then 2. So we do -2, then -1, then 2. So we're looking at the intervals from infinity to -2. And here, because we're talking about the equal to at the beginning of the problem, we're going to use actually, for right now, we're going to go ahead and just keep the parentheses, and we'll talk about the brackets later on. This way we don't get bogged down on if it's a bracket or parenthesis before we get to the end of the problem. So we have all these different sections here. So we have to try something for each one. And so with this, I'm going to try, for the first one, -3. For the second one, I'm going to try between -2 and -1. I'm going to try -1.5. Between -1 and 2, we're going to try 0. And then between 2 and positive infinity, we're going to try 3. Oh, buddy comes. Buddy comes. All right. So again, when we're trying numbers out, we're going to try numbers that are inside that interval there. And we're not trying to use the boundary lines because that's where things change and switch. So we don't need it at the boundary line. We need it to be inside. Okay, so here we're going to substitute it into the original to the function that we did in step 2. So that function was, let me go back really quick, right here. So we're looking at putting everything into this function of x cubed plus x squared minus 4x minus 4 equals 0. Okay, so we're going to try these in, and again, if it's positive, that means it's greater than 0. If it's negative, it means it's less than 0. For our function that we're looking for, if you go back up top to example, for step 1, we said that it needs to be less than 0 again. So when we do this, we're looking for those that are less than 0, the negative numbers. That's the part we're looking for. That's what we need. All right, so for each section, we said we're going to try specific numbers. So let's try -3 here first. And again, that means for every function here, we're going to put 3, every x, sorry, we're going to put 3. Let's put parentheses around that. Sorry, that should be cubed. Squared. And again, we don't need the equal to 0. I'm sorry. I keep doing that. I don't know why. All right, so we do that part. And when you put it in, we get a -10 as your answer. So that means here, this is f of x is less than 0. So that means that's going to be part of our answer choice because it's less than 0. It's a negative number. All right, second one we said we're going to try -1.5. And again here, we're going to substitute -1.5 in for everything. And here I would encourage you to go ahead and put it in the calculator because there's so much work that's happening here that the arithmetic part is not really the most important. The putting it into the function in the calculator to find these values are not the most important part. It's the process, but there's a lot of process here. So it's best to go ahead and, I would say, go ahead and put this in the calculator, do it, get the answers. This part of it. All right, so we get a positive 0.875. Which means f of x is greater than 0. So that's not going to be part of our solution. So far, we know this first part here is going to be part of it. The second one will not. We know that. All right, let's go ahead and try the next one, which is 0. I have to say 0, right? Yep, I said try 0. All right, so we're going to try 0 in this, and that should be something that's very quick, because you can look at it really quick and tell me what the answer is. So that's -4. And so again, this is f of x is less than 0, because it's a negative number. So that's going to be part of our solution set. All right. And then we try the last one, which we said was 3. So let's try 3. Whew, that's a lot, guys. It's a lot of work. A whole lot of work. But it's going to be okay, because we're going to persevere. We're going to make it through this thing. Because we got this. You got this. You got this. Put the 3's in there. And again, put in the calculator, get the answer there. And you should get an answer of 20. Which means, again, f of x is greater than 0. So it means we don't use that part as our solution. Not at all. Okay, so with that, what we're going to do is go ahead and take a look at all the parts that work. And begin, and again, because we're talking about it's less than or equal to, that's what our original function was. So we know for step 5, our solutions are from negative infinity to -2. We know it's from -1 to +2. With it again, we know it's parentheses on infinity. But with our brackets and parentheses, because the original had an equal to sign right there, an equal to sign, that means here we use brackets on each one of these. So for polynomials, we can do this. Because polynomials, remember, there are no gaps or holes in the function. So therefore, if there's no gaps or holes in the function, that means we can go ahead and say that it's all going to be brackets. When it comes to our rational functions, one more time, remember they're asymptotes and stuff, just like we talked about with the graphing. They're the actual asymptotes and stuff, then holes in the graph that can happen. So you have to actually do some work there to make sure that you know which one is you're dealing with. All right, so with that being said, let's jump really quickly back to what we said again to make sure that was the answer that we originally said was going to happen with our graphing. Step 2, said negative infinity to -2 and then -1 to -2. And that's exactly what we said when it came to with using the graphing. Cool, so we did it.